Let me start with introducing myself. I am Faisal Ibne Rizwan. I'm a visiting fellow at University of Southampton, but I have another hat that I wore. I'm a lecturer in bioinformatics in Cranfield University. Thank you all for coming to this talk. This talk or this project is part of my fellowship application. So it will be very beneficial for me to know your ideas. So from the um, title, you say it's predicting lung function from recorded speech, an AI artificial intelligence approach. Just to let you know that my background is in computer science, and we computer geeks are kind of cursed with jargon. So I may tend to talk lots of jargons, but I will try to avoid as much as possible. Just to start with, what's my research question for this project? It's very fair and simple. Can we predict lung functions from recorded speech file for asthma patients? And to do this, can we use any kind of technology? It does not have to be AI. It does not have to be uh, statistics or something very sophisticated, but any kind of method that we can use so that we can predict or measure the lung function from the recorded speech file. So the main motivation actually came from my collaborator, Professor Jude Holloway at University of Southampton. The idea she had was normally physician, if they want to diagnose acute asthma, they give patient ask patient to read text for a minute, and then they observe how the breathings are coming in and out, and based on that they can say whether the patient is asthmatic or non-asthmatic. So there's something in the speech and breathing which can help you to identify asthmatic or non-asthmatic, and which may affect the lung function of the patients. So the idea, light bulb moment she had, and what she did is she recruited 26 volunteers. Among them, 8 of them were non-asthmatic, and recorded over 300 voices, and with matching lung function, which is here. It was FEV1. Sorry for the jargon. It's forced expiratory volume 1. You may know it already. It's you take breath and then you exhale for 1 second, and then you count it as a percentage. And so how from 26 volunteers can you get over 300 recordings? All these volunteers went through Met-Collin challenge, and when they had Met-Collin challenge, their lung function dropped, and they were given text. They spoke for a minute, and it was recorded, and their lung function was also recorded. So based on that, what initially is done, the recording, the tracks were provided to some specialist, say healthcare specialist, who works with asthma, where people having asthma, respiratory problem, nurses, doctors, and ask them to estimate the lung function. So the estimated lung function and the actual lung function, it was amazingly found highly correlated. It was not the same, but highly correlated. If somewhere the actual lung function went up, the estimated lung function also went up. If the actual lung function went down, the estimated lung function were also down. So that was the initial work. So there's something in the recorded speech that may predict the lung function. So, but the moment of truth, the frustration, the traditional statistics was not successful to find any features from the recording that can relate to lung function. So that can measure the lung function. So from that point, I started collaborating with Jude, and I was already working. I am actually already working in AI, artificial intelligence. I said, oh, let's give it a try using AI. So you will, in this kind of talks, you will hear about AI, machine learning, deep learning. So these are almost is the same thing. So machine learning is a part of AI, is the whole umbrella term. So if I talk about AI or machine learning interchangeably, it's the same thing here. So I'm not going to explain or give you the background what AI or machine learning really means. It's just a sophisticated statistical method. What it will be easier if we know what its function really is. So the main one of there's two function. AI or machine learning has two function. One of the function is prediction. What machine learning tries to do, tries to make predictions about future data based on past data. So there are some buzzwords here: making predictions, future data, past data. Where do we stand in this sentence? For us, the past data is all our recordings with the matching lung functions. So what we'll try to do, we'll try to find a way so that we can uh, take those recordings, and we will try to match with the lung function that we already have. In AI term, this is called training. And then we'll try to predict the new lung function from the future data, which is the new recording. And this is called testing. So the one thing, or validation. So one thing, if you hear about machine learning, you will hear a lot is training and testing. So it's the same thing that Catherine did to her cat. She gave her some treat and it went down in that table and kept itself quiet or watching the people. So you are so it's like you're training a machine rather than a cat, saying, "Here's my recording, and here's my lung function. Observe this, and if I now give you new recording, can you tell me what the lung function can be?" So that's one of the thing that AI does. The second thing that AI does, it tries to discover if there's any hidden pattern in the data. Yeah, machine learning is very good in that. So in machine learning, we normally work with big data set, complex data set. Here, our data set is the recording. What we have done, we took one recording file, we listen to the recordings, we listen where the person spoke and where he or she stopped, and we just took separated those two parts as a speech part and breathing part. And if we use machine learning to see how different they look, so this is kind of like, it's called energy diagram. It shows how much energy is there in the speech and breathing. So if you can see, in breathing it's very consistent, and in speech there's ups and downs, which means there's, just to let you know, that there's some feature is there in breathing and speech which can be extracted to identify where's the breathing going on, where's the speech going on, and maybe some of these features are also related with lung functions, maybe. So this is mainly what AI does, but it's not limited to only these two functions. So this is the workflow. What we did, we took all the recordings, we separated breathing and speech in every recording. Initially we did manually just one or two to see where the threshold is, and once we got the threshold, and then we automatically, we separated all over 300 recording sample. Once we separated the breathing and speech part from the recording, we extract feature from breathing part and speech part. And we also took account of basic physical attributes like a person's sex, age, whether they smoke or not. And then we accumulate all the data. So the one of the important thing about machine learning is you need to clean your data. So we clean the data set. I'm not going to the nitty gritty part of how we clean the data. So we have the dirty data set that we just cleaned it. And then we have all these features got from the breathing and speech chunks. Like these are the features, and here's your lung function. Now let's train. And we train the machine or the technique, and then we try to validate. So the way we normally do, if we have a data set, we divide it in two-third, and we take two-third as for training, and one-third we keep absolutely hidden from our training. So it's an unseen data set, and we train on that training, two-third training set, and take that and then try to validate on the test set. So that's in a nutshell what we have done in our work. So the results, initially what we have done, we have taken lung function as a continuous values, the percentage predicted FEV1, and we did the same thing for all of the different methods we have done. And we have found this 60% of accuracy, that 60% accurately we can predict the lung function, which means the rest of the 40% was not correct, was wrong. And there's a reason for that. One of the reason is machine learning normally takes huge data set, and 300 sample, though it sounds very big data set, it's not. It needs thousands of data set. But this is like a pilot project that we have started with. The second thing we have done, we divided each of the sample or recording based on its severity. So we took the classification of the lung function severity based on American Thoracic Society, ATS, and we have 6 class, and we again run our model or machine learning model, and this time it will not tell you what's your lung function, rather than it will tell you the range of your lung function. And using that, we have over 73% accuracy. And then what the last thing we have done is simply we said, if it's percentage predicted FEV1 is over 80%, then it's a normal lung function. If it's lower than 80%, then it's an abnormal lung function. And using the same method, same technique, we have over 84% of accuracy. So these are very preliminary results that we have with the method that we have used so far. So wishful thinking, what we want to do with it, the end product is we want to develop a mobile app that can predict lung function from recorded speech. So you will speak to your mobile, and there will be an app, and it will tell you, hey, this is your lung function, something like that. And you can record your lung function, and you do in the next day and say, okay, there's 10% drop or 20% drop or something like that. Maybe you need medication, you need to go to have a talk with your physician, or even we can have something like a centralized database. If people are comfortable with that, it can be recorded in the centralized database so that your GP will be able to see what your lung function is. I can see the trend. So this is just like snapshot what we are trying to do. So we'll have an app, something like this, and we'll ask people that hold the phone close to your mouth, read the text appear on the screen, and then there'll be instruction. So hold the phone comfortably close to your mouth, and then press the recording button and start speaking. And once you're finished, just press the stop button. Once you started, press the record sample. There will be a text will appear. We are still working on that. So this is a rainbow text we call that have a lot of ups and downs with breathing. And once we have finished, you have finished talking, just press the stop button and it will tell you something like this. Say your if percentage FEV1 is 90%, which is normal, or 40% within the range of severely abnormal, something like that. It will also show the severity index. So these are just the idea. We haven't yet done anything, and that's the idea that's going on. Why it's important? So initially, I was thinking, okay, people can have a peak flow meter, which is 10 pound worth, and people can easily blow in the peak flow meter and can measure their lung function. Why they need this extra app to measure the lung function? So I had a friend who she has asthma, and I started discussing with her, is it really worth doing? And she said, yes, it's worth, because sometime people, she said, I don't really feel to take my pixelometer, blow and record, and then put against the chart and then write it down. And I feel very, very lazy to do that. So yes, that can be one important thing. But then you also have solution, new kind of digital pixelometer where you can just attach with your app, mobile phone, and you blow, and then it will do everything for you. But you cannot do it everywhere. For an example, currently the COVID situation, you cannot take it out and then bring out and do it, take in your mouth and blow it. So one importance of this project, it will empower the patients for self-monitoring of asthma and for early intervention if anything needed, any kind of medication is needed. So the visit to hospital will get less. It will open up the use of alternative technology for measuring lung function. So this is still in a very early stage of the project. We are open for any kind of technology, and that's one of the things that we really want to see, whether any other technology rather than the current one will help to measure the lung function. It's a non-invasive, low-cost, affordable, easy and fast technology because it's just an app. It will be an app, not just an app. It will be an app, and if it will be free, and people can easily do it using their smartphone, and obviously save money for NHS, and it will take the burden out of NHS. These are all wishful thinking, but there's still a long way to go. For an example, we're talking about speech, and different language will produce different results. Myself, I'm an Asian guy, I'm from Bangladesh, and I tend to speak faster. Uh, People in other part, they tend to speak maybe slower. And also the breathing up and down, if I take with my own language, is quite different. So different this will be the problem. And then in the same language, different accents may affect the result. We have collaborator from Brazil, and he told us that Portuguese spoken in Brazil is quite different than the Portuguese spoken in Portugal. So it's the same language with different accent will completely produce different results. One of the easier option is, rather than sentences or text, we can have monosyllabic vowels like A or E or Z or something like that. Then the patient or the person will be more comfortable rather than saying the whole sentences. So this is, I'm at the end of my talk. So this is the work I did with Professor Jude Holloway. And this work was initially done by Nicholas Taylor, and all the AI work was done under my supervision, done by started with Raffaello Brillantino and Albino Simonotti from Italy and Jahangir Alam from Bangladesh. And also University of Newcastle, Australia, they are also are one of the collaborators. Just to add something, based on this project, we are trying to build NIHR Global Health Group, and we are trying to collect speech and breathing and lung function from countries from Sri Lanka, Brazil, Angola, South Africa, Ghana, and we are trying to enrich our data set as much possible to see how the work that we are doing will also help countries where they don't have the access of peak flow meter. So yes, that's all. I'm happy to take any kind of question